Hello, my friends. I'm Clover, and this is Genuinely Approachable Sudoku. And today we are solving Three is Company by Philip Newman. So, this is a difference and ratio pairs Sudoku. And that means we have some black dots and white dots in the grid. So, first of all, we have normal Sudoku rules. So, we're placing the digits 1 through 9 once each in each row, each column, and each outline through a 3 region. And then in addition to that, we have difference pairs and ratio pairs. So we have marked black and white dots in the grid. So a black dot tells you that the two digits on either side of the dot are in that ratio. In this case, all of the black dots are marked with a 3. And that means that the digits are in a 1-to-3 ratio. In other words, one of them is 3 times as big as the other. The white dots tell you that the difference between the two digits on the either side is whatever the marked value is. So in this case, again, they're always 3. So two digits on either side have to have a difference between them of 3, such as 1 and 4, or 2 and 5, or 3 and 6, etc. Because this is a pairs puzzle, not all of the possible differences have necessarily been given, so there may be other differences in ratios of 3 in the grid that haven't been marked with a black dot or a white dot. So let's have a look at the puzzle. So we're going to start with some of the ratios. So 3 is in a 1-to-3 ratio with 1 and 9. So all of these black dots that are adjacent to a 3, we're going to mark with either a 1 or a 9. And then also the white dots that are adjacent to a given 3 tell us something, because the only digit that is exactly 3 greater or less than 3 in a Sudoku is 6. So we can definitely mark those as 6 immediately. And that tells me there's a 6 in one of these cells, and there's a 6 over here somewhere. Now I'm going to see if I can place some additional pairs on the black ratio dots. So here, 6 is in a 1-to-3 ratio with 2. That's going to be a 2. This 1-to-3 ratio doesn't have a 3 involved in it. So again, that's going to be 2 and 6, because the only possibilities are 1 and 3, 2 and 6, 3 and 9. And 2 of those have a 3 in them somewhere. This one also doesn't have a 3, so that's going to be 2 and 6 again. And I think that is all we get out of the black dots. So now we're going to focus on our white dots. 2 is 3 away from 5. 2 is 3 away from 5, which is 3 away from 8. 6 is 3 away from 3 and 9, but because there's already a 3 there, we have to place a 9. And that actually resolves a lot of the 1-9s that we were unsure about. Now, what next? In this row, I still need 4, 7, and 9, and that can't be a 9. So if we focus over here, 1 is 3 away from just 4, and 9 is 3 away from just 6. So if I go from 1 to 4, then my next digit would have to be 7. And if I go from 9 to 6, my next digit would have to be 3. And that case is impossible, so this must be 1, 4, 7. Which makes this 4, 7, and 9 in the row. Now there's only one possible position for 2 in the central region. It has to go there because the other cells are seen by these 2s. These are going to be 1, 4, and 8. This cell already sees 1 and 4. That's already seen by 1, so that's going to be a 1. And 1 is 3 away from 4, and 2 is 3 away from 5. Here I need to place a 7 and 8. Here I need to place a 7. And here I need a 6 and a 9. And I'm going to need a 5 and an 8 to finish off this column. I need a 4 somewhere in this column. Oh, and that's already on a 3 difference dot with a 1, so I can place that immediately. Here I need a 7 and 8. Here I need 5, 6, and 9. Those can't be 6, so that's going to be my 6. And then 6 is 3 away from 9, not 1. And that resolves a few cells via Sudoku. These are now 7 and 8. If this is a 7, then it's 3 away from 4. If this is an 8, it's 3 away from 5. I don't know which is which just yet. 4 has to be 3 away from either 1 or 7. There's a 1 in the row already, so that's going to be 7, making this a 1 and an 8, which resolves that 7, 8, and also places a 5 for us. Now there's only one position left for 4 in this region, and the last 2 digits in that region are going to be 2 and 9. That makes these 2 digits 5 and 6. And then right here, I need to place a 5 and a 9. Here I need a 2 and a 7. Here I'm going to need a 4 and an 8 to finish. And here I need a 5 and a 7 or 8, and that is not yet resolved. I need 6, 7, 8 to finish the column. The only position for 6 there is right here. The 9 resolves the 5, 9, which resolves the 8, 5. 5 is 3 away from 2 or 8, but it already sees an 8, so I'm going to place my 2 right there, which resolves this 2, 7 pair. This is now a 4, and now I need a 1 and a 7 to finish the region. And that 1 and 7, I believe, are going to take care of the rest of the grid via classic Sudoku. And that's how you solve Philip Newman's Three's Company. Hope you enjoyed that one. If you want to check it out yourself, the link to do so is in the description below this video. And I will see you again in a couple days.